This is Module 5, the final video. What we're going to do here first is open up the Rossmann Chance applet and have it simulate this sampling words experiment that we did. We went through and picked 10 words from the speech ourselves and kind of did a poor job of it. And then in the second video, we went through and used a random number generator to pick 10 words, and that worked out really well. And now the Rossmann Chance applet is going to go through and pick random words and then repeat again and pick another 10 words, and then repeat again and pick another 10 words over and over and over again, as if there were thousands of students picking random words from the speech. So I'm going to the Rossmann Chance applet collection. I'm clicking over here on the sampling words applet, and you'll see that it has the entire speech loaded in here. There it is, 7 years ago, all the way down to the last word, the 268th word in the speech, which is Earth. So over here, there is a button that says Show Sampling Options. If I click that and I say that I want to take one sample of sample size 10, what it will do is randomly pick 10 words from that speech. It tells me in this box what the 10 words are. It says the words are pour, consecrate, 7, or etc. So it picked 10 words. Down here in this little graph, the blue dots indicate the length of each of those 10 words. So for example here, the first word that it picked was pour, which has word length 4. And you'll see here there are 3 dots above the 4 to indicate that apparently it picked 3 different words that have word length 4. Up here, it looks like there was 1 dot at 10, so there was one word it picked that had 10 letters. Let's see. Oh, that's consecrate. Consecrate has 10 letters in it. And then underneath the graph, you'll see that it has a little triangle, blue triangle, and the number 4.900. That is the X bar. It is the sample mean for this set of 10 words that it randomly picked. So on average of this 10 words that it randomly picked, the word length was 4.9 letters long. It then comes over here to the right side and it makes a little square at the 4.9 to indicate the sample mean was 4.9. I'm going to repeat. I'm going to hit the draw sample button again. It draws a new sample of 10 words. There they are, the 10 word lengths. There was one word of length 2, 4 words, it looks like, of length 3, and so forth. And it looks like the sample mean word length for this sample was 4.1 letters long. And if you come over here to the right side graph, we have a new little block at 4.1. And over here was the sample mean that we got the first time, which was 4.9. So here's 2 samples, and here are the sample means. And if I repeat and repeat, I'm clicking draw samples over and over and over, the graph on the left is showing the actual word lengths of the 10 words together with the sample mean. And on the right, it's plotting the sample means. Okay, and I could click, but instead of just clicking, I'm going to just up this to like 1,000 samples, and it's going to do this 1,000 times. So it's as if I had 1,000 students each pick a random sample of size 10 and calculate their sample mean. Then I would have 1,000 sample means, and then over here on the right, we're making a little dot plot of those sample means. Instead of dots, they're little squares, but it's the same idea. It is making a little distribution of sample means, a distribution of sample statistics. So I'm going to hit draw samples. There they are. Okay, so I can see here in the graph that the distribution of sample means has a mean of about 4.28 and a standard deviation of about 0.648. And I've done 1,048 total sample means here shown in this distribution. It asked me to identify the most recent sample and the sample mean from that. As you see over here, the most recent sample was 4.1 was the sample mean. So that most recent one means that the most recent sample of 10 randomly selected words had a sample mean word length of 4.1 letters long. So on average, that sample of 10 words was 4.1 letters long words on average. On the right side, we saw the distribution of sample means. That's this distribution here that I copied and pasted. What's the shape of that distribution? It is approximately bell-shaped. It's not perfect because it's from a simulation, and simulations are not going to ever be perfectly mathematically theoretical models, but it's close. What is the mean of the distribution of sample means? So if we look at our picture here, the mean of the distribution of sample means is 4.28. And that makes sense because we know that our distribution of sample means should be centered at the population mean. And remember, the population mean is 4.29. So it's 4.28 instead of 4.29, and that's because it's a simulation, and so it's not going to be perfect, but it's pretty close. So it said back in problem 13a, we calculated a sample mean from our sample of 10 words. Identify our standardized statistic for our sample mean that we had calculated. So back when I had done this back in number 13a, way back here, when I collected my random 10 words, I got a sample mean word length of 4.6 letters long. A standardized statistic in this situation would be a t-score, because we're talking here about a distribution of sample statistics that are quantitative, a distribution of x bars. So we're going to use a t-score, and the t-score will equal the statistic minus the mean of the null, and then we divide by the standard deviation of the null. So in this case, our statistic was 4.6. Minus the mean of the null distribution was 4.28 in my simulation, divided by the standard deviation in the simulation was 0.648. Notice I'm using the values from the simulation to get my t-score here. If you divide that out, we get 0.49. I'm just going to say approximately 0.5. So the t-score is about 0.5. That's saying that my observed sample mean of 4.6 letters per word is only half a standard deviation above the mean of the null distributions. In other words, this is an expected sort of sample mean to get if the true population mean is 4.29. And we're not even hypothesizing the true population mean is 4.29. We actually know in reality the true population mean is 4.29. So we got a normal, usual, expected sort of sample mean given the fact that the mean of the population is 4.29.